In this video, we will solve problem 1.16 from the book Heat Transfer JP Holman 10th editions. Water flow at the rate of 0.5 kg per second in a 2.5 centimeter diameter tube having length of 3 meters. So it is the mass flow rate that is provided, that is 0.5 kg per second. And what is the diameter of the tube? That is 2.5 centimeter. Divide it by 100 to convert into centimeters. From centimeter to meter, that will be 0.025 meter. Tube having a length of, what is the length of the tube? That is 3 meter. A constant heat flux is imposed at the tube wall so that the tube wall temperature is 40 centigrade higher than the water temperature. So it means that the wall temperatures is greater than the fluid temperatures, and its difference is 40 centigrade. That is 40 centigrade. That is the statement of this. That is the meaning of this statement. Calculate the heat transfer and estimate the temperature rise in the water. So we need to find the heat transfer that is taken place from the tube wall to from this tube wall to this fluid, that is water. So this is the diameters of this tube. The temperatures of this wall is TW, and the temperatures of inside fluid is TF, and its difference is 40 centigrade. Okay, so the dia is D and the length of the tube is L. So it is obvious that when the heat transfer is taking place from this tube wall, heat transfer will take place from this tube wall to the fluid, because the tube wall is at a higher temperatures as compared to the fluid temperatures. So we need to find that heat transfer that is taken place from tube wall to the fluid. And also, when there is a heat transfer taken place from the tube wall to the heat transfer, there must be temperature rise of the fluid. Okay, so this is convection heat transfer. As heat transfer will take place from the wall to the fluid is convection types. So for convection heat transfer, we need convection heat transfer coefficients H, and that we can find from this table 1.3. The type of the mood, that is water flowing 0.5 kg in a 2.5 centimeter diameters, and this is the case. Then take the heat transfer coefficient 3500 watt per meter square, 3500 watt per meter square centigrade. So the heat transfer you will get, that is H, area, surface area, and temperature difference. So what is H? That is 3500. What is area? That is equal to pi d L multiplied by temperature difference. H is 3500 multiplied by pi. D is the dia of the tube, that is 0.025 multiplied by length, that is 3 meters of the tube, and temperature difference, that is 40. So you will get the heat transfer after simplifications, and that is 32,987 watt. This is our first answer of this statement, and that is the heat transfer that is taken place. Next, we need to find the temperature rise of the fluid. We know that the heat that is transferred to the fluid is stored, and that is equal to this formula. So heat, the Q is equal to Cp m dot delta T. So this is the rise in temperatures of the fluid that we need to find. So what is Q? That is 32,987 is equal to Cp value, that is constant 4.18, multiply by mass flow rate, that is 0.5, and temperature difference, that is we need to calculate. Remember, this 4.18 is in kilo, so you will need to multiply this with 1000. So after simplifications, this on the calculators, you will get the temperature rise of the fluid, that is 15.78 centigrade. And this is our final answers of this statement. I hope you understand. If you still have any confusion, you can ask in the comment sections. I will respond you accordingly. Thank you so much for watching.